The Rails 3.1 Hackfest took place last weekend, and thanks to all the hard work of those who participated, the 5th release candidate of 3.1 is now out. Now this includes some important fixes to a feature I've been wanting to show off, which is Mountable Engines. Now Mountable Engines is like mounting one Rails app into another. Let me show you here. Now some of you may remember the exception logger plugin. This basically stored your exceptions in a database and gave you a nice interface for browsing through them. Now in this episode I want to remake this plugin, but through a mountable engine. First, make sure you're using Rails 3.1, Release Candidate 5, or newer. If you don't have this, you can just gem install Rails --pre to get it. So now we can generate our mountable engine. Now first of all, notice that I'm not in a Rails application here because this is almost like generating a new Rails app with the Rails new command. So to generate one, you call Rails plugin new, and then give it a name. So I'm going to call this because it's dealing with exceptions. And then you pass the --mountable option here, so that makes it a mountable engine. So now let's open this up and see what it gave us. First of all, you'll notice that this looks a lot like any other Rails application, and it basically is, but it's just one that's designed to be mounted inside another one. Another thing you'll notice is that there's a lot of namespace directories going on here where everything is namespaced under the engine name, which is And this will keep everything nice and separated from everything else in the application that it's mounted in. And you may also notice that we have assets. So you no longer have to worry about copying these assets into the public directory when the application gets mounted, because thanks to the asset pipeline, it'll all just dynamically handle this for us. And notice that assets are also namespaced under that directory. So this means when you link to your assets, you always need to go through that namespace. And you can see this inside the layout file. So if we check out our views directory here under layouts, and actually I think there's a bug here because we have two layout files, and you can just delete the one that's outside of the namespace directory if you see it. Hopefully this will be fixed soon. But if you check out the layout file inside of here, you notice that it's always referencing assets underneath the namespace directory here. So whenever you're linking to images or any other assets, be sure to include that namespace. Now let's check out one of the key files that makes up an engine, and that is inside the lib directory here. Notice that we have a file called engine.rb, and this is a class which inherits from Rails engine. And this is sort of the central location where you can put custom configuration, and notice there's already a line here that says isolate namespace, And this basically means it's going to treat this engine sort of as its own isolated unit and not worry about everything around it that's in the app you mount it in. Now our final stop of this whirlwind tour is inside the test directory. Notice that inside of here, we have a little dummy test app here. So this is actually a Rails app on its own, and it's sort of an example of how to use this engine. So it's sort of this is what it would look like mounted inside of another Rails app. And if you check out the config directory here, you can see that you have a routes file. And this has an interesting line here called mount, and then it's passing in the engine name and assigning it to the path. So this is what someone will have to do when they install your gem here, is to mount it to any kind of given path that they want. Now notice this uses the engine class that I showed you earlier, and this is a true rack application here. So we're basically just saying if a request comes in to this path, just pass it on to the engine rack application. Now it's a good idea to add this line to the installation instructions inside of your README so that the users know that this is how they mount the application in the routes file. Now even though this dummy app is inside of the test directory, it's still useful for manually testing as well. If we run the Rails server command, it's actually going to boot up that dummy application. Now if we go to localhost port 3000/, that's actually going to go to our engine because that's where it's mounted in our dummy app. Now if we hit return here, it's actually not going to do anything because we don't have any controller to handle this yet. We can use the generators just like we do in any Rails app, so we can generate a controller here, and it's not necessary to do the namespacing. It'll automatically handle that for us because it knows it's inside of an engine. So let's generate a controller called failures and give it an index action. And notice that generated everything we expected a normal controller generator, except it's namespaced. Now if you look inside of the engine's config directory, you'll notice there's a routes file where you can customize the routing for the engine itself. Now we can make a custom a root route here to point to that failures index action that we just made. So now if we reload our browser, instead of a routing error, it now points us to the index template action here, which was generated. Now what I want to do here is list out the exceptions which were raised, so we'll need a model of some kind to store them in the database. So let's generate a model here inside of our engine, call it failure, and to keep things simple, I'll just give it a single column here called message. And as we expect, it put the model inside of a namespace here. Now how do we handle the migrations though? Well, inside of the engine itself, we can just run rakedb migrate, and everything will be handled automatically for us. However, this will not work when someone tries to mount this engine inside of their application, because it's not going to pick up the migrations which are inside of mounted engines. To get around this, you have to instruct the users of the gem to first call rake install migrations, and that'll copy over the migrations from the engine into their own app so that they can run rakedb migrate and generate the tables properly. So be sure to include this in the installation instructions of the engine you're making. Now the Rails console works just like you expected as well, so just start it up like normal. Now while you're in here, just be sure to include the namespace whenever you're referencing a class. So we can create a failure here, and include a message saying hello world, like that. So now that we have a record in our database, let's display that on the index action in our failures controller. Now it's not necessary to specify the namespace here though, because we're already inside of the namespace in Ruby, and the way the lookup works, it'll just automatically pick it up. So that's all that's needed. And then inside of the index template, I'll just paste in some code to loop through the failures and display them. And then when we reload our page here, you can see there's our failure message we generated, so that works. So now all we need to do is just generate these failure records whenever an exception is raised. So we need to somehow simulate the raising of an exception inside of the dummy application. So if we change into the test dummy directory, we can run Rails generators inside of here to simulate the environment that the engine is intended to be mounted into. In this case, we need some place to generate an exception. So let's generate a controller with called simulate and give it a failure action. And then inside this generated controller, we can just have this action raise an exception. So let's just say simulating an exception. So now if we try to visit that controller action, simulate failure, we get that exception which is raised like we expect. Now we just need to change our engine so it listens for this exception and creates a new failure record. Now my solution for this problem is not very efficient, but it's just a simple solution that will work for our case. Now what I want to do is first create an initializer, and if you look under the config directory of our engine, there's no initializers here, but we can create one, and it seems to be fully supported by engines. So we'll just make a new folder here called initializers, and then inside of here, let's make a new file. Sure, let's call it exceptionhandler.rb. Now I'm just going to paste in some code to handle this tricky job for us. Now notice here I'm subscribing to a notification. Now I covered notifications in detail in episode number 249. So I'm basically listening to a notification that a controller action was processed. And if the payload contains an exception, that means an exception was raised while it was processing. And if you see here, it's going to parse through the exception and get the message, and then create a failure with that message. So that should create a failure when we raise an exception. Now don't forget to restart the server, but after that, just hit reload here, and to simulate the exception again. And now if we go to /uh-oh, it should show, yep, simulating an exception because it caught the notification and created the failure record. Now a quick word about URLs. While you're inside of an engine, any URL helpers you use will be for that engine. For example, while we're in our failures page, let's say we want a link. Let's just link to the same page, which will be the root URL. So let's link to failures, and that goes to the root URL. This will be the root URL for the engine itself. For example, if we reload our browser here, you can see we have this failures link, and that actually goes to this exact same page because it's the root URL for the engine, not the root URL for the app itself. Now you're able to access URL helpers for the app itself by prefixing it with main app. So if we say main app.root URL, that will go to the root URL for the app itself and not the engine. Now, since we don't have this, we have our simulate failure path page that we can use instead. Let's just call this simulate failure. And now if we reload, we now have our simulate failure link, and this will take us to the application's simulate failure page here. Now let's say we're on the other side of the situation where we are inside of the dummy application and we want to link to a page that's inside of the engine. Well, the first step is to go into your routes file where you call mount and then pass in an as option and say whatever name you want for the engine. Let's call this engine. And then you can go inside of your controller. In this case, we'll go to our simulate controller, and you can use the URL helpers through that. So temporarily here, let's just remove the raise command, and we can say engine, and then call root URL and access the root URL here. So let's just redirect to that URL. So now when we try to go to our localhost port 3000 simulate failure page, it'll take us to the engine's root URL page because we're going through that engine helper. So that's how you link to a page that is inside of an engine. Now you may want to mention this inside of the README for your engine that you're making. And I'll just restore the original functionality of raising an exception here. So the functionality of our engine is pretty much done, but the page itself is looking a little dull, so let's spice it up with some assets. First, let's add an image to the top of our failures page here. Now I already went and found an image off camera, so I've already added it here. So let's just include it at the top here. And just like any other image, we'll use image tag and then point it to alert.png. There we go. And reloading our page here, we can see there's our fancy alert image. Now let's include some styles. So under my style sheets, I'll just paste in some code under the failures.css file here. Now Sass and CoffeeScript aren't available by default in these engines, and you may or may not want to add them as dependencies, so I just won't use them here. But you can see if I reload the page here, it looks quite a bit nicer now. So this style sheet code was just picked up by default. We didn't have to do anything. So the same thing goes with the JavaScript. Let's just add some JavaScript code to our failures JavaScript file here. This will just slide up each section in our list if we click on it. And try reloading our page here and clicking on an item in this list, and notice it automatically slides up. So that JavaScript was automatically picked up and handled by the asset pipeline without us having to do anything. Well, that wraps up this episode on creating a mountable engine. I hope you enjoyed it. A really awesome feature in Rails 3.1. I can't wait to use it more. Finord Metric allows you to track and chart various events in real time, such as user activity in a Rails application. The interface is quite clean, allowing you to easily browse the charts. In this episode, I'll show you the basics of getting this set up and how to integrate it with a Rails app. Let's get started. Now, Finord Metric stores its events using Redis, so you'll first need to install that. I'll use Homebrew here to install it. There we go. Now I can start it up manually using this command. Now that we have Redis up and running, let's set up Finord Metric using an example provided in the README. Unfortunately, I have some trouble with the simple example out of the box. However, the full example provided here is a good showcase of what Finord Metric is capable of. So I'll make a new file here. I'll just call it fullexample.rb. And then I'll just paste in the example code provided by the README. Let's try running this. First, I'll need to run gem install Finord Metric. And then I can start it up by calling Ruby and passing in that full example script. You can see that this is now listening on a couple of different ports. 4242 is the web application, and 2323 is where you can post new events. So I'll try visiting localhost port 4242 to get the web application, and there we go. So this is showing me charts for various events, and it's just filling in this data from the script, and you can see it updates in real time. And there are various other gauges and stuff you can browse through here to see various distributions, and you can see what keywords are searched and most popular and so on. Now if we take a look back at the full example script, you can see that there is a DSL provided for defining the gauges which appear in the user interface. And you can make an event call and pass in a block which will listen to that event and then affect the gauges as instructed in the block. And then near the bottom of this script, we can see how it's populating the events. Right here is creating a new Fnord metric API, and then calling event on this, and passing on a specific type, and then whatever other attributes it wants to send along with the event. So this is just looping through and triggering these events at random intervals, which is generating the data which you saw in the charts. Now that you understand the basics of Fnord metric, let's take a look at how to integrate this into a Rails app. So here's the app, which contains a list of products, and what I want to track is when a user visits a single product. When this happens, I'll send an event to Fnord metric, and then I can chart that information in various ways. The first thing I'll do is go into the gem file for this application and add in the gem for Fnord metric, and of course you run the bundle command to install it. Next, I'll go into the config initializers directory and create a new file in here for setting up Fnord metric.rb. So in here, I'll instantiate a new Fnord metric API object, and let's assign this to a constant, so that way I'll be able to access this anywhere throughout the Rails application. Now be aware that this is opening a new connection to the Redis database, and it will insert events directly into there. So that's more efficient than going through the open port, which is another way to add events through Fnord. Next, I want to trigger an event inside of the products controller show action, which is the page I showed you earlier. And the way we do this is just call Fnord metric and then call event on this, and then we can pass in whatever parameters we want into here, such as the product's attributes. Now it's also important to pass in the underscore type parameter, so that way we can give this event a name. So let's call it view product. So with that set up, now whenever I visit a product, it's going to add an event to Redis. Now I just need to set up a Fnord app to listen to this event and adjust any of the gauges. So I'll just make the script at the root of my application. I'll just call it Fnord metric app.rb. And then I'll paste in some boilerplate code to get us started. So I'm just requiring Fnord metric here and then defining a namespace called store, which is the application. And this is where I can define any gauges. And then I'm starting up the worker and the web. And notice I'm not starting an acceptor because I can define events and add them directly into Redis. Now there are several types of gauges which are provided. The first I'll show you here is called a top list gauge, and this will allow us to list out the popular products. And I'll give this a title of popular products. And then next I need to make a new event listener, so I'll listen to the view product event and then pass in a block. Now I can instruct this event to observe the popular products gauge we just set up, and then tell it to use the name of the product in the list. So this data hash is what we sent in through the Rails application when we triggered this event. All right, now I can start up that Fnord metric app, and this will launch it on port 4242. And when I visit that, I get this blank page, and it's currently on this active users section, which I believe primarily just shows you the events that have come in, but no events have come in at the moment. And if I check out the popular products gauge I set up, you can see this will list out the products that have been visited, but currently nothing is here. Now off camera, I went to a product in the Rails app, so let me try refreshing this, and there's the product. And I just visited several other products as well, and then refreshing this shows them all listed here, with the most visited at the top. Now manually triggering each one of these events is sort of a pain, so you might want to set up a rake task which will automatically do this and simulate real-world activity. Now before I do that, I'm going to move this Fnord metric event trigger from the controller into the model, so that way it will clean up the controller a bit more, and that way we can trigger it from a rake task as well. So I'll make a method called trigger view event, and then going into the product model, I'll define that method, trigger view event, and then paste in that same content and adjust it here slightly because we're currently in this instance. All right, now I can make a rake task for populating these events. I'll do that inside of the lib tasks directory, make a new file here. Let's call it fnordmetric.rake. And I'll paste in the code for this. It's quite simple. I just make a Fnord metric populate task, which loads in the Rails environment, and then it fetches all the products and just randomly triggers the view event for that product and sleeps a random amount of time between 0 and 1 seconds. So let's try this out. When I trigger that rake task, it's going to run continuously in the background and populate the events. And now as I refresh this page, I see a lot more samples coming in here, and the list will adjust as well and show me which products are currently going up or down. Pretty cool. Next, let's add another gauge to see which product price ranges are most popular. So I'm going to paste in a distribution gauge here called popular prices and supply a range of values which will determine how the bar graph is displayed. Now I need to observe this one as well, so I'll add a new observe call here for the product prices gauge and use the price data for that graph. Now while we're here, I'm also going to add a call to the top to hide active users. So what this will do is remove that active users menu option on the left because that page isn't all that useful, at least at the moment. Now you'll need to restart this app each time you make a change, and then once you do and visit it, we can see that there is a popular prices gauge, and visiting that will show us a bar graph of distributing the prices based on which ones are most visited. But keep in mind that this is going to weight a little differently depending on how many products are in each price range. Now I want to show you one more gauge, so I'm going to paste this one in as well. So this is just going to do a generic gauge call, and it's for making a product views per second gauge, and I'm setting the tick to 1 second. So when you're doing a generic gauge call, you usually supply a widget option as well, which will define how that gauge is displayed. And notice this allows me to do auto updating for that, which is quite nice. Now I do want to adjust this gauge whenever I receive a view product event. I'll just tell it to increment that gauge when that happens. So now when I restart the app and visit it, it's showing me the product views widget, which I defined, and has this graph here which auto updates for each hit that's coming into the products, and you can see the activity live right here. Really cool. Well, that's it for this brief look at Fnord Metric. If you want to track events in your Rails application, definitely check it out. Unfortunately, I didn't find a whole lot of documentation on this gem yet. Probably the best source is just the full example that's provided down here, but I expect that it will be improved later on. Maybe we can get a full wiki of documentation up soon. Also, if you're deploying this to production, you're currently on your own on how best to do that. There's some solutions on embedding this into a Rails application, but I think it's best to run it as a separate process. This way you ensure there's only one instance running, and you can easily manage the memory that way. Well, that's all I have for this episode, but a quick reminder before I go, in case you missed the announcement, starting this week I'm switching to 2 episodes per week, and this means that free episodes will be every other week. If you have any questions or comments on that, please feel free to email me at ryan@railscast.com. In the pro episode this week, I show you how to create template handlers in Rails. It's surprising how making something as simple as a Ruby template can really bring a lot of power and flexibility to your views. To watch that episode and gain access to all previous Pro and revised episodes, visit railscast.com/pro, and you can sign up there for just $9 per month.